I'm Erin Bridges, and this is Science Weekly. On this week of Science Weekly, we'll be talking about the famous physicist Max Planck.
Erin, why don't you tell us a little bit about Planck's early life?
I would love to. So, Max Planck was born in Kiel, Germany on April 23rd, 1858, and he was the son of Julius Wilhelm and Emma Planck, and his father was a professor of constitutional law at the University of Kiel and later in Göttingen. And Planck was always interested in physics at an early age, and he also excelled at his other subjects, and he was also a talented pianist. And Planck ended up studying at the universities of Munich and Berlin, where his teachers included Kirchhoff and Helmholtz, and he received his doctorate of philosophy at Munich in 1879. Okay, Allison, would you mind telling us a little bit more about his adult life?
Yes. So during the period of the Nazi government, he felt it was his duty to stay in Germany. He suffered a tragedy when his house was destroyed in result to a bombing. More about his personal life, though, is Planck was twice married. Upon his appointment in 1885 to associate professor in his native town, Kiel, he married a friend of his childhood, Mary Merck, who died in 1909. He remarried her cousin, Margot von Hoslin. 3 of his children died young, leaving him with 2 sons. He suffered a personal tragedy when one of them, Erwin Planck, was executed for his part in an unsuccessful attempt to assassinate Hitler in 1944. Max Planck then died at Göttingen on October 4th, 1947.
Allison, what is Planck known for?
Well, Planck is best known for as being the originator of the quantum theory of energy. Planck found that energy carried by electromagnetic radiation must be divisible by a number now called Planck's constant, represented by the letter H. Energy can then be calculated for the equation E equals hv, where E is energy, H is Planck's constant, which is 6.626 times 10 to the negative 34th joules squared, and V is the frequency of the electromagnetic radiation. Planck's constant is a very, very small quantity indeed, and its small size explains why the experimentalists of the time have not realized that the electromagnetic energy is quantized.
Awesome. So on top of that, what are Planck's most notable works?
I would say that Planck's most notable works would be his Planck's constant, which is the number 6.62 times 10 to the negative 34th joules squared, which I already mentioned before, and also the originator of the quantum theory, which we now use in physics. I also want to touch on why his work is important for science and in everyday life. He was awarded a Nobel Prize in Physics in 1918 for creating a new branch of physics. Quantum physics has helped explain some pieces of understanding our solar evolution. And Planck's constant tells us how the universe is numerically fine-tuned to permit life to exist.
That's so interesting.
Erin, what areas of physics did Planck study?
Planck primarily studied theoretical physics, while he also contributed to the origins of quantum physics. He also worked with light often and realized that light and electromagnetic waves were emitted in discrete packets of energy, which he called quanta, thus referring to quantum in the singular. Because of his discoveries, he is widely considered the founder of quantum theory.
Erin, what kind of experiments did Max Planck conduct?
Well, since Planck mostly worked as a theoretical physicist, most of his experiments were purely theoretical, so they weren't actually performed in real life. So yeah, he didn't really conduct many experiments, but he was still a very widely known physicist. So Planck's accomplishments were also related to what we learned in Miss Ayler's class, because as a class we spent a lot of time talking about Planck's constant, which is, as Allison said, 6.626 times 10 to the negative 34th. And Planck's constant, which is also related to in terms of H when talking about equations, relates to the energy of one quantum photon of electromagnetic radiation to the frequency of that radiation.
Thank you so much for joining us on this week's Science Weekly episode.
We'll see you next week for another discussion on an amazing physicist.